Geometry students, similar to previous lessons in this unit, there is a lot, but I hope most of it is review or formalizing things we already know. Start with trapezoids. Trapezoids are a type of quadrilateral with exactly one pair of parallel sides. So trapezoids cannot be parallelograms. Parallelograms require two pairs of parallel sides. We call those parallel sides the bases. And for each trapezoid, there's two pairs of base angles. In this example, there's angle A and angle D, and there's angle B and angle C are base angles. So it's important to know that. We call the non-parallel sides legs. The legs are not necessarily congruent, but they can be. Then there's a special segment in a trapezoid, and it's called a mid-segment. It takes the midpoints of the legs and connects them. It doesn't take much to prove that the mid-segment is parallel to the bases. Remember, triangles have a mid-segment. If we connect this here to this midpoint here, so what's interesting about the mid-segment of a triangle is you can easily prove that it is half of whatever this side is, the side it's parallel to. We did that in the similar triangle chapter. So if this is 4, this is 2. Another way to think about that is this point up here is 0, and what's the average of 4 and 0? It's 2. I bring up that way of thinking about it as an average because it works with this theorem that says if you have a mid-segment for trapezoids, the distance between the distance between these two midpoints, the length of the mid-segment, is actually half the sum of the two bases. So that works like an average. Take base AB and add base DC, get that sum, and then divide by 2. It's an average of those two bases. Interesting way to think about it. In addition to trapezoids, there's a special subset of trapezoids where the legs are congruent, and we call those isosceles trapezoids. Some things to think about here. You could easily put in a diagonal here and a diagonal here. And what we could prove is, well, we know this side here is the same as this side here. We know that this side is congruent to itself. So I'm looking at these two triangles right now. The base is congruent to itself, right? You've got this. Good. Cool. So something to think about. You could prove that this angle here is the same as this. That doesn't really help necessarily. You could prove that this angle here is the same as this. That doesn't necessarily help. We've got this angle congruent to this angle by vertical angles, right? So lots of stuff to do there. I'm blanking right now on how we prove that this angle here is the same as this. I guess one thing we could do, and I don't love this proof, is maybe we could drop a perpendicular here, and we could drop a perpendicular here. Good. Then I could say, because these are the distances between two parallel lines, I know they're congruent. And because I know they're congruent, I have a hypotenuse congruent to a hypotenuse, a leg congruent to a leg, so these triangles are congruent. So I can get that those angles are congruent. Once I get that those angles are congruent, I can easily show, because this angle is the same as this angle, and these two lines are parallel, then this angle is supplementary to that, and this angle here is supplementary to that. And because these two angles are supplementary to congruent angles, they must also be congruent by the supplements theorem. Then once we get those angles congruent, we can go back to this these two triangles I was talking about earlier, where you have leg here of the isosceles trapezoids. Now we know these base angles are congruent, and then we've got that the diagonals are congruent. So here are a couple of those theorems. If a trapezoid's isosceles, then each pair of base angles are congruent. If a trapezoid has a pair of congruent base angles, then it's isosceles. So this could be written as an if and only if. A trapezoid is isosceles if and only if The base angles are congruent. And then the last one, if a trapezoid is isosceles, if and only if its diagonals are congruent. So that's kind of interesting. That's just like rectangles, congruent diagonals. So some good theorems there to look in your book for. In addition to, we have all of these shapes now as we start to kind of put together a big picture. So I've got this huge four-sided, not necessarily trapezoid thing. So we'll just make it here, not a trapezoid. So this is all the quadrilaterals. And inside the quadrilaterals you have parallelograms. And inside parallelograms you have rhombi and you have rectangles. And inside rhombi and rectangles you have squares, right? So this is rhombi and this is rectangles. Good, and this is squares. Well, we just talked about trapezoids, and then there's a subset called isosceles trapezoids. So here's traps and isotraps. And then the last one we want to talk about is a special shape called a kite. So notice there's lots of quadrilaterals that are not one of these special things, but there's a couple of special types of quadrilaterals and they have interesting properties. A kite is a quadrilateral with two pairs of consecutive sides that are congruent, but the opposite sides are not congruent. What I like about this is it's easy to draw a diagonal here and get two isosceles triangles. So I know this angle is the same as this, and I know this angle is the same as that, and then I can prove, all sorts of things. If I draw this other diagonal in here, it wouldn't be hard for me to prove that we have perpendicular diagonals here, that the diagonals of a kite are always perpendicular. Couple ways to prove that. The other thing that we can do is I can draw in just this diagonal here, and I can get two triangles congruent by side, side, side. So I know this angle is the same as that. I know this angle is the same as this angle. I know that angle there is the same as that angle there. And then when I draw this second one, then it's easy for me to say, oh, look, I've got side congruent to side, I got side congruent to self, I got angle congruent to angle, so I know these triangles are congruent. I know that these two angles form a linear pair and they're congruent, so they have to be 90 degrees. So lots of properties to prove there, that the diagonals of a kite are perpendicular and that the opposite angles, exactly one pair of opposite angles are congruent. And they're the angles between the non-congruent sides. So I know that's a ton of information. Hopefully you pause the video a lot to write down those theorems. I'm not asking you to prove any of them directly for homework. And then your classwork on Monday is to work with trapezoids and kites, and then your classwork on Tuesday is to review. There are some review things in classwork on Monday that will be homework for Tuesday because there will be no video for homework Tuesday. So you got lots of work to do to get ready for a test on Thursday, but I know you can do it. All right, peace.